So the question given, decide among the following sets which sets are subset of one and another. Here given a set is x belongs to R, a real number, x satisfy x square minus 8x plus 12, x square minus 8x plus 12 equal to 0. If we solve that, this will be like x square minus 2x minus 6x plus 12 equal to 0, which will result in 2 and 6. So we get the set A is 2, 6. So here given B is 2, 4, 6, C is set of all even numbers, even natural numbers, and D is 6. So what we can say, D, the smallest set only containing the element 6, is the subset of A. A contains 2 and 6, which is subset of B. It contains 2, 4, 6. Extra element is 4. So it also, B is also a subset of C. Why? It contains 2, 4, 6 and all other even natural numbers. So we get this. If we write individually, then the answer will be A is subset of B, A is subset of C, and B is subset of C, and for D, D is subset of A, D is subset of B, and D is subset of C. This is the answer. The next question is, determine whether the statement is true or false. If it is true, prove it. If it is false, give an example. Now the first question is, if x belongs to A and A belongs to B, then x belongs to B. So we are taking an example first. Okay, let us consider, let 2 belongs to A. Okay, so and we are considering the set A as 1, 2, 3. So this will satisfy 2 belongs to A. Now there will be a set, we are satisfying this portion first. Okay, so the B will be like we are considering like 0, 1, the set 1, 2, 3, the set 3, 4. Okay, now here 2 belongs to A. Yes, 2 belongs to A. A belongs to B. Yes, it's satisfied that this set is belongs to B. Okay, this set is belongs to B. So A belongs to B is also satisfied. But you can see 2 does not belongs to B. There is no element 2 in this set. It's in the set, but it's a combination of elements. Okay, so 2 doesn't belongs to B. So if we can prove it for one example that it is false, the statement will be false. So next problem is, if A is subset of B and B belongs to C, then A is subset of C. A belongs to C. We have to show that A belongs to C. So we are considering A as a set 1, 2, and B is 1, 2, and 3. Okay, so A is subset of B is satisfied from this example. Now it's written that B belongs to C. So C set will be considered as let us assume 0, 1, 2, 3, and 7. This is the set C, and here B is belongs to C. This element is actually B, so B belongs to C. This statement is also satisfied, both the statement. Now we see that 1, 2, the set is not present in C. Okay, 1, 2, 3, the combination of elements, the set 1, 2, 3 is present, but 1, 2 is not present. So we can write A does not belongs to C. Okay, so the statement is false. Now the next question is given, if A is subset of B and B is subset of C, then A is subset of C. Let us consider A as 1, 2, and B is A is subset of B, so B will be like this. So the condition is satisfied. Okay, A is subset of B, 1, 2 is the element of B, 1 and 2 are elements in the B, and C will be superset of B, that is B is subset of C. That means we have to satisfy this condition also. The two conditions are satisfied. A is subset of B and C is, we are taking 1, 2, 3, 4. So B is subset of C. Now we can clearly see that A is subset of C. Okay, but this is just an example. Okay, we cannot conclude from the example that the statement is true. Why? If it is true, prove it. We have to prove that. For false statement, we can show only one example that is false. For true statement, we just can show only a single example. We have to prove it for general. So we will be proving it from the definition. What is the definition of subset? First, let x belongs to A. if A is subset of B, what will be the definition? X belongs to B. If X belongs to A, it will imply X belongs to B as A is subset of B. Any element of X will be an element of B. Okay. Now what? X belongs to B implies X belongs to C as B is subset of C by definition. Okay. Now what we can see, since X belongs to A implies X belongs to C, we can write A subset of C. For any general term X, we proved that the X, if X will belong to A, X will belong to C. Then by definition A is subset of C. We can write by definition. This is the proof statement. This is proved. Okay. This statement has been proved. Okay. Now what is our next question? If A is subset of B and B is subset if A is not a subset of B and B is not a subset of C, then we have to show that whether we have to check whether A is not a subset of C or not. Okay, so we consider A as a set 1, 2, B as a set suppose 8, 9, 10. So clearly A is not subset of B, we can see from here, and C we are taking 1, 2, 3, 4. Okay, so here also B is not a subset of C. Okay, but you can clearly see is A is subset of C. 1, 2 is present here, so A is subset of C. So we have to only show one example is not true for false statements. So this statement will be false. So the next question, if X belongs to A and A is not a subset of B, then X belongs to B. We have to check the statement is true or false. So let us consider A as 1, 2 the set and B as 7, 8, 9. Okay, this is a set B. Okay, so clearly 2 belongs to A and 2 is an element of A, and B is a set. If this condition also satisfies, A is not a subset of B, and we can see that 2 does not belongs to B. Neither does 1 does not belongs to B. Neither 1 nor 2 is the element of B. So the statement is false. Okay. So our next question is, if A is a subset of B and X does not belongs to B, then X does not belongs to A. Let us consider an example. A is 1, 2, B is 1, 2, 3. Now 5, an element does not belongs to B. Okay, and 5 does not belongs to A. It seems it's a true statement, but if it is true, we have to prove it. Okay, now the no element in the set B, 5 is not an element in the set B and 5 is not an element in the set A. This is an example. Okay, now so how we will prove that? Let X belongs to A. Okay, we are considering X is an element of the set A. Now as A is subset of B, as A is subset of B, which implies what? X belongs to B. Why? If X belongs to A and A is subset of B, by definition it will be an element of B. It is by definition. By definition X will be an element of B, but X does not belongs to B. So this is a contradiction. This is a contradiction. You have to write this is a contradiction because of this statement. So what we have assumed that is incorrect. Therefore we can write X does not belongs to A, and this statement is true. First we have to consider X is belonging to the set A. We have to contradict this first. Then as A is subset of B, X will be an element of B because of the definition. As per definition, if X belongs to A, then X will be an element of B if A is subset of B. But it's given in the statement X does not belongs to B. So this is a contradictory statement. So X will not be an element of A. Our next question is, let A, B, C be the set such that A union B is equal to A union C and A intersection B is equal to A intersection C, so that B is equal to C. So let us consider first X belongs to B. Okay, X is an element of B. As X belongs to B, we can say that we can imply that X belongs to A union B. Since B is a subset of A union B, we can write by definition X is an element of A union B. Now X belongs to A union C also. Why? Since given A union B equal to A union C, we are just changing in place of A union B, we are writing A union C. Now what does that mean? It means X belongs to A or X belongs to C. Okay, so case 1, we are writing case 1. Case 1 is X belongs to A, X belongs to A, and what we know that X belongs to B. This is we considered, so we know X belongs to B and we have X belongs to A. What does that mean? It means X is element of A intersection B. X belongs to A and X belongs to B means X is element of A intersection B, common element. Now X is an element of A intersection B means X is an element of A intersection C. Why? A intersection B is equal to A intersection C. Okay, now what does that mean? It means X belongs to A and X belongs to C. So we started with X belongs to A, B, and we ended with X belongs to C. X belongs to B implies X belongs to C from the case 1. And from case 2, what is case 2? Case 2 is X belongs to B means X implies X belongs to C. From the case 2 we got similar result, same result actually, similar not. And what does then what we can say, if X belongs to B implies X belongs to C, then B is subset of C. In the case 2 we also get B is subset of C. Similarly, if we consider the same, just like that, X belongs to C, and we do the same procedure like X belongs to A union C, that is X belongs to A union B, X belongs to A, or X belongs to B. So if we start from that point of view, instead of going from X belongs to B, we will get same result, that is X belongs to C implies X belongs to B from case 2 and case 1 both. Okay, with similar results we can get C belongs to C subset of B. And so we can write that similarly, considering X belongs to C, we can show that C is subset of B. So B is subset of C and C is subset of B implies B equal to C. You can check that by considering this, the case 1 X belongs to A, doing the same, just this will be opposite, it will be A intersection B, A intersection C, this will be A intersection B because they are equal. That will give us X belongs to A and X belongs to B, and then if X belongs to C implies X belongs to B, we will get this. So this will be the proof. So our next problem is that, so that the following 4 conditions are equivalent. Before solving this mathematically, let's try to understand this with diagram. This is Venn diagram, this is universal set, we are taking a set A and this is a set B. Okay, so the first condition is satisfied, A is the subset of B. Okay, now A minus B equal to 5. Is this satisfied? If we eliminate elements of B from A, what we will get? Nothing. The A itself got subtracted from itself, so the set will be 5. And the next one is A union B. If we union A with B, A and B, the whole set will come out as a result, so this will be B. Okay, and if we take intersection between A and B, then what will happen? This will be the set A intersection B. The common elements between A and B will be this is A intersection B. And what is this? This is the set A itself. Okay, so now we will be solving this problem mathematically. So we will be starting from this 2, 3, 4 condition and end in condition number 1. Why? Because I think it's a easy procedure. Why? Because we know the simple definition of subset. What is the definition? If X belongs to A implies X belongs to B, then A is subset of B. This is the definition. If any element belongs to A implies that element also belongs to B, then A is the subset of B. Okay, so we will start from number 2. Okay, so here what we say, let X belongs to A. Okay, so we can say clearly X belongs to B. Why? Otherwise if x does not belongs to B, then A minus B not equal to 5. Let us simply take an example. Okay, suppose A is a set 1 2 3. Okay, we are subtracting from B, that is 2 3 4. The result will be singleton set 1. Why? There is a exist an element 1 in the set A which does not belongs to B. If 1 does not belongs to B, then the subtraction result will not be 5, the null set. So if x belongs to A, that we must imply x belongs to B. 1 must be in B to get the result 5. Okay, every element of A will be in B, must be in B to get result 5. So as x belongs to A implies x belongs to B, we can say that A is subset of B. Okay, number 3 is very easy. Let x belongs to A. As x is belonging to A, so Ax must belong to A union B, because A union B means x is either in A or in B. So or in both, maybe in both. Okay, x so here x is in the set A, so x must be in A union B. What is the value of A union B? Is B. So x belongs to B. We can say that x belongs to B since A union B equal to B given in the statement. As x belongs to A implies x belongs to B, then A is subset of B. We can write A is subset of B. Number 4, it's also easy. Let x belongs to A. Now implies x belongs to what? A means A intersection B given in the statement. Since A equal to A intersection B given. What is the definition of intersection? It means x belongs to A and x belongs to B. There x is the common element of A and B. So x belongs to A and x belongs to B. Here or here is and. So we get x belongs to A implies x belongs to B. So by definition A is subset of B. This is how we will prove this problem. So our next problem is question number 5. So that if A is subset of B, then C minus B subset of C minus A. So from the previous problem, we know the definition of subset. Okay, so what we have to show to prove this? Okay, what is the plan to execute this problem? If x belongs to C minus B implies x belongs to C minus A, then C minus B is a subset of C minus A. We have to show this x belongs to C minus B implies x belongs to C minus A. Then this will be automatically stated. Why? This is the definition of subset, just like the previous problem. Okay, so this is our plan. This is our plan and this is our goal. Okay, so we start with let x belongs to C minus B. We started with this. Okay, so let us understand first. This is a universal set, this is C set, this is B set. Okay, what is the C minus B? C minus B means the red portion. Okay, the red portion is the C minus B part. So now what does that mean? By definition, x belongs to C. X is inside the element set C, x element, and x does not belongs to B. X isn't in the set B, you can see from the diagram. Okay, now what we are implying? X belongs to C and x does not belongs to A. Okay, where is A? A is just like here. This is the set A. Okay, so you imagine if since we can write that A is subset of B, so if x does not belongs to B, then x does not belongs to A. Any element which is not present in B, that will not present in A. Why? A is subset of B. Suppose we take an example. 1 2 is set A and 1 2 3 4 is set B. So 5 is not in set B, then 5 will also not present in set A. Suppose this is A, this is B. Okay, this is from the diagram you can also understand this. Okay, so what does that statement means? X belongs to C, x does not belongs to A. It means x belongs to C minus A. X belongs to C minus B means x belongs to C and x does not belongs to B, and x belongs to C, x does not belongs to A means x belongs to C minus A. So we achieved our statement that x belongs to C minus B implies x belongs to C minus A. We started from this, we ended here. So by definition by definition C minus B is subset of C minus A. Just we have to plan how to solve it, and then we have to execute the problem. This is how we can solve this problem. Now what is our next question? Assume that PA is equal to PB, power set of A equal to power set of B, so that A equal to B. So how we will solve that? Our plan is how to achieve this. We have to show that A is subset of B and B is subset of A. Then it will be automatic A equal to B. Okay, we have to show this and this. To show this, what we have to show? We have to show X belongs to A implies X belongs to B. Then it will be achieved. And for this we have to show Y belongs to B implies Y belongs to A. Then this can be achieved. So this is our plan how to solve this problem. Okay, so first we are solving this portion. Okay, now we are separating this. We will be solving first this and this. Okay, now so to solve A subset of B, let X belongs to A. X is any arbitrary element of A. Okay, so then there exists a subset, say S of A such that X belongs to S. So there X is an arbitrary element in A, and there is a subset S of A which contains the element X. Now it is obvious that S is subset of A. We assume that S is subset of A. Okay, so S will belong to the power set of A. Why? Power set of A contains all the subsets of A. So definitely S will be a member of power set of A. Now we are saying that S is also a member of power set of B. How? Since given power set of A is equal to power set of B. Okay, it's given. So S is also element of power set of B. Now what are the elements of power set of B? The subsets of set B. All the subsets of set B are in the power set of B. So S must be a subset of B. All the subsets are in the power set. So if S belongs to power set of B, then S must be a subset of B. So now X is a element of S, set S. X is a element of set S, and S is now subset of B. This is S and this is B. You see that? This is S, this is B. Okay, this is the universal set. So if X belongs to S, then X must be inside B. If X is an element of S, then X must be an element of B. So we started with what? X belongs to A, and we implied what? X belongs to B. Then what we can say? A is subset of B. So we achieved this. Now we have to achieve this one, B subset of A. So for that let Y belongs to B. So then there exists a subset, say T, of set B such that Y belongs to T. Okay, so Y belongs to B, and there is a subset of B which contains the element Y, which is T. Now T is subset of B. We assume that. Now as T is subset of B, T must be belonging to the power set of B, because power set of B contains all the subset of B. So T must be an element of this. But now T belongs to power set of A. Why? As given P of A is equal to P of B. Power set of A equal to power set of B. Okay, it's given. Now what are the elements of power set of A? All the subsets of A are the elements of power set of A. So T is also must be a subset of A to be an element of power set of A. So T will be subset of A. Now same here, this is A, this is T. So Y belongs to T. Y is an element in T. So the element Y must be an element of A, because T is subset of A. Okay, so Y must be belonging to A. So we started what? We started with Y belongs to B implies Y belongs to A. Then we can say that B is subset of A. We achieved this. Now as A belongs to A is subset of B and B is subset of A, we can write what we can write A is equal to B. This is by definition. If A is the subset of B and B is the subset of A, we can write A equal to B. We planned the problem and we solved by the planning. Okay, this is how we can solve this type of problem. So is it true for any sets A and B, power set of A union power set of B equal to power set of A union B? Is it true? This statement for any set is not true. Okay, this is not true. So we have to justify our answer. Okay, this statement is not true. So for justification, let A is equal to singleton set 1, B is equal to singleton set 2. So you may ask why I have chosen only singleton set. Why not a set containing multiple elements? Because we know the number of elements in power set is 2 to the power m. If we if we consider set containing 2 elements, the number of elements will be in power set is 4. For 3, we will get 8 elements in the power set. And as we consider only one element in the power set, only in the main set, so the power set number of elements in the power set will be 2. To reduce the size of the problem and labor invested to solve the problem, I consider only singleton sets. That's the reason. Okay, so from here we can say that A union B will be 1, 2. Okay, now power set of A will contain the null set and the singleton set 1, and power set of B will be the null set and the singleton set 2. Okay, and what about the power set of A union B? Power set of A union B will be the null set, the singleton set 1, the singleton set 2, the set 1, 2, the union B set itself. Okay, as it has 2 elements, the power set will have 4 elements. 2 to the power 2 equal to 4. Now P of A union P of B, that is the left hand side. Okay, what is the value of it? The sets containing P of A union P of B will be 5, singleton set 1, singleton set 2. That's all, and which is not equal to P of A union B. The element 1, 2 is extra in P of A union B. P of A union P of B contains only 3 elements, whereas P of A union B contains 4 elements. So they are not equal. This is the this is an example to show that's not true. If for any example it's not true, then the statement is wholly not true. Because in the statement it's written for any sets A and B, and A and B are 2 arbitrary sets we have chosen. So if for one example it is not true, then for as a whole the statement is not true. So our next question states that so that for any sets A and B we have to show this. So A intersection B union A minus B equals A intersection B minus union. We can write this A intersection B complement. Can we write this? Let's check whether we can write this or not. This is a small Venn diagram. Okay, this is A, this is B. Okay, this is A, this is B. What will be the portion that will show A minus B? This is the portion. This is the set A minus B, shaded portion. Okay, so what is B complement? If we draw another Venn diagram just like this, this is A and this is B. Suppose this is B, this is A. What will be the set B complement? B complement will be all the elements of universal set apart from the elements of B. If we eliminate B from the universal set, we will get the the B complement set. Okay, so if we take intersection between A intersection B complement, okay, A intersection B complement, so A and B complement, we are taking intersection. The common elements are these, the shaded portion A minus B, so they are same. Okay, so I have shown you by diagram, they are same. Okay, so from this we are using distributive law. So this will be A intersection B union B complement. This is distributive law. Okay, this is distributive law. Okay, so now B union B complement means B union B complement, the whole universal set. A intersection universal set. If we take intersection between universal set and A, what will we get? We get the set itself. So this is proved. Now for the second part, it is A union B minus A. So let's write it like A union B minus A can be written as B intersection A complement. Just like that, A minus B means A intersection B complement, B minus A means B intersection A complement. Okay, now again we are going like this, A union B intersection A complement. Sorry, A union A complement. There is a union A complement. Okay, so this will be A union B intersection. A union A complement means A and A complement, that is the whole universal set. If we take any set intersection with universal set, if we take any set and take intersection with that with the universal set, we get the same set, the set itself. So A union be the result. Now our next problem is using properties of set so that this is equal to this, this is equal to this. First we solve the first problem, A union A intersection B. So by the properties of sets, this is A union A intersection A union B. Okay, so what is A union A? A union A means A intersection A union B. So what will be the intersection between A union B and A? This will be the A. A union B contains A and A is itself A, so their intersection will be A. This one is proved. Now the second question is A intersection A union B. Okay, so we have to solve this. Okay, so by using the properties of set, A intersection A union A intersection B. Now A intersection A is A union A intersection B. Now A intersection B means the common elements between A and B, and union the set A is answer will be itself the set A. Okay, this is the common elements of A and A and B, that is elements containing in A, and we are taking union with A. The answer will be A. So our next problem is, so that A intersection B is equal to A intersection C need not imply B equal to C. Okay, so we are going to solve this by taking example. Let okay, A is equal to set, we are taking 1 2 3. Okay, B is a set, we are taking 2 5 we are taking 2 4 6. Okay, and C is a set, we are taking as 2 5 7. Now here A intersection B equal to, the common element is 2, A intersection C equal to common element is 2. So A intersection B equal to A intersection C. There is no problem with that. Now B is equal to C, whether B is equal to C, B have 2 4 6, it has 2 5 7, so B does not equal to C. So this is how we can show that A intersection B is equal to A intersection C need not imply B equal to C. So our next problem states that let A and B be sets if A intersection X is equal to B intersection X is equal to 5 and A union X equal to B union X for some set X, so that A equal to B. So to prove A equal to B, we need to show that A is subset of B and B is subset of A. That will conclude A equal to B. This is the way we can solve this problem. Okay, so what is given? Given that A union X equal to B union X. Okay, so we are taking intersection on both sides with A. Okay, so A intersection A union X equal to A intersection B union X. Okay, we are getting that. Now A union X means both the elements of A and X. Okay, all the elements of A and X. Okay, we are taking the sets. If we take intersection with A, the result will be A. The common element between A union X and A is A. Okay, now we are using distributive law here, that is A intersection B A union A intersection X. What is this? This is distributive law. Now here given that A intersection X is 5. Okay, so A equal to A intersection B union phi. Okay, that is A equal to A intersection B. So now look, A intersection B is A. What does that mean? That means this is B, this is A. Okay, the bigger set is B, the smaller set is A. Only then if you take B intersection A, the answer will be A. In any other cases, the answer will be different. Okay, only this case. That means A is subset of B. You can take any other cases, like if you take like this is B, this is A. Okay, this is B, this is A. Their intersection will not be A. Their intersection will be this portion. Okay, and if you take the bigger set as A and the smaller set as B, then their intersection will be B, not A. So only this condition satisfies A is equal to A intersection B. That is A is subset of B. Okay, so we are going for the other part given B. Sorry for the problem. B union X is equal to A union X. Okay, this is given. B union X is equal to A union X. Instead of going with A, we are going with B now in this side. B intersection B union X equal to B intersection A union X. Same procedure, just we are using, instead of A, we are using B. Okay, so this portion A union X intersection A, we are taking intersection of B union X intersection B. B intersection B union X. What will be the term? B. Just like it became A, this will become B. Now we are using the distributive law. So this will be B intersection A union B intersection X. Just like this, the distributive law. Now B equal to B intersection A and union, this is B intersection X, that is given phi. So we are taking phi. So union of phi and B intersection A will be B intersection A. Now look, A intersection B is A. So B intersection B will be B only if the case is like this. That is, A is the bigger set and B is the smaller set. Only then A intersection B will be the set B. In any other cases, the result will be different. So we can conclude from here that B is subset of A. We are taking this as A subset of B and B is subset of A. We conclude that A equal to B. This is how this problem can be solved. So our next problem is find sets A, B, C such that A intersection B, B intersection C and A intersection C are non-empty sets and A intersection B intersection C equal to phi. So there will be lots of sets supporting this condition, but we will be making as small set as possible with lesser elements. Okay, you can increase the elements, the set will be bigger and this condition will be satisfied with lots of sets. Okay, so first we are taking only two elements of A, that is 1, 2. Okay, now we have to construct set B such that A intersection B is non-empty and A intersection B intersection C equal to phi. So to make A intersection B non-empty, there should be a common element between A and B, that is we may say 1. Okay, 1 is the common element between A and B, so we are using 1 and the other element we are making different. We are using 3 as the other element, so A intersection B will be 1. Now we have to make B intersection C a non-empty set. So there will be a common element between B and C. If we write here 1, okay, if we use 1 in here, A intersection B intersection C will be 1. Okay, if we use 1 in here as a common element, then A intersection B intersection C will be 1. So we don't want that, we want null set. So we are not taking 1 as the common element, we are taking 3 as the common element. Okay, 3 as the common element. Now we have to make A intersection C a non-empty set. Okay, A intersection C a non-empty set. So we can't use 1 because if we use 1 in C, A intersection B intersection C will be 1. Okay, so we have to avoid that. So the remaining element is 2. So we are using 2 here. So there is a common element between A and C 2, that is 2. Now we can write here A intersection B is 1, B intersection C is 3 and A intersection C is 2. This is the easiest one. and also A intersection B intersection C is 5. There is no common element between A, B, C. You can see all three have different elements. Okay, no common elements between A, B, C simultaneously. So we get this is our answer. Okay, we construct. You can construct a lot of sets with different elements. So our next problem states that in a survey of 600 students in a school, 150 students were found to be taking tea, 225 taking coffee, 100 were taking both tea and coffee. Find how many students were taking neither tea nor coffee. Okay, so what will be the universal set? Let U be the universal set, and number of elements in the universal set is the number of elements, number of students in the school. Okay, so n of U is 600 given. Now let T denote the set of students taking tea. Okay, you can write that in notebook, that T denote the set of students taking tea. So how many students are taking tea? N of T will be 150. Now let C be the C denotes the set of student taking coffee. So N of C will be 225. Okay, now here given 100 were taking both tea and coffee. Okay, so both tea and coffee means the intersection T intersection C will be 100. Okay, so given data is that, so we have to find out how many students were taking neither tea nor coffee. Okay, so before finding that, we need to find how many students were taking at least one of tea or coffee, at least one of tea or coffee. Okay, at least one of tea or coffee, anything either tea or coffee, and the set including both tea and coffee, at least one of tea and coffee. We have to find the set. What is the set? This is the set. The set T union C is the set which contains the elements. Elements means the students who take at least one of tea or coffee. So number of elements in T union C is equal to, by formula, is equal to n of T plus n of C minus n of T intersection C. We are putting the values. This is 150, this is 225, and this is 100. So we can calculate this. This is 3. Okay, sorry, 3. This is 275. Okay, 100 minus 150 is 50. 50 plus 225 is 275. Okay, now we can find how many students were taking neither tea nor coffee. What will be the set? The set will be T union C complement. It is the set taking at least one of tea or coffee. This is the set containing students, they are taking neither tea nor coffee. So number of elements in this set will be this. Number of the total universal set minus number of elements in T union C. Okay, so the universal set is given 600, and this is given T union C given 275. So the answer will be 325. So let us make the graphical example. Okay, this is universal set, it contains 600. Okay, and here this is suppose set T, this is suppose set C. Okay, now so T, what is this is so T intersection T union C is this, T union C is this. This is the set containing the intersection and both the sets. Okay, so if we denote the complement one, the complement set is this. You can see X there. This is the set there. Sorry, this will be not in the inside. This is the set of students who taking neither tea nor coffee. This is how we solve this problem. So next question states that in a survey of 60 people, it was found that 25 people read newspaper H, 26 read newspaper T, 26 read newspaper I, 9 read both H and I, 11 read both H and T, 8 read both T and I, 3 read all 3 newspaper. Find the number of people who read at least one of the newspaper, the number of people who read exactly one newspaper. Okay, so we will solve this using Venn diagram. Okay, so first we will using Venn diagram, then we will use formulas to solve this. First using the easy method, Venn diagram. So this is newspaper H, this is newspaper suppose T, and this is newspaper I. Okay, so what is the common portion? Common portion means the newspaper, the people who read all 3 newspapers. Okay, this is the portion of the people who read all 3 newspapers. What is the number? 3 read all 3 newspapers. This is actually H intersection T intersection I. This is the value is 3. Now we have to fill up the other portions. Okay, so H and I, how many? This intersection is H intersection I. The people who read both H and I, given by H and I. 9 read both H and I. So this will be 9. It is 3. How many will be there? That is 9 minus 3 means 6. Okay. Now between H and T, how many people read both H and T? 11 read both H and T. Okay, this portion is H and T, the common portion, H intersection T. 11 minus 3, how many will remain? 8. Okay. Now between T and I, so the people who read both T and I is 8. So here is 3, that is 8 minus 3 is 5. Okay, so we have to fill the other portions too. So 25 people read newspaper H. Okay, 25 will be reading this H newspaper. So this will be 25 minus, here it is 6 plus 3 plus 8. Actually it will be 9 plus 8 means 17. That means there will be 8 in here. Similarly 26 read newspaper T. That is 26 minus 8, 3, 5. 8 plus 3 plus 5. That means it's 11 plus 5 means 16. Yes. So it will be 10. This will be 10. And for I 26 read newspaper I. So this will be 6, 3, 5. 26 minus 6 plus 3 plus 5. That is 11 plus 14. 14 minus 6, 26 minus 14. That is 12. Here it will be 12. Okay. So let's solve the problem. It will be quite easy. Number 1. So the number of people who read at least one of the newspaper, here all the people reads at least one of the newspaper, at least. Even if you read multiple newspaper, there will be no problem, because it says at least. You can read multiple newspapers. There is no problem in that. So here all the people in here mentioned here are reading at least one of the newspapers. So we just have to add those. So 8 plus 10 plus 12. Okay. Then plus, there is 8, 6, 5. 8 plus 6 plus 5 and plus 3. The answer will be 18. 18 plus 12 is 30. 30 plus 8 is 38. 38 plus 6 is 44. 44 plus 5 is 49. 49 plus 3 is 52. Okay, number 2 question. There is 52 number of people who read at least one of the newspaper. Okay, and the number 2 is the number of people who read exactly one newspaper. Here mentioned exactly. Okay, exactly one newspaper. So 8, 6, 5, these numbers are for the common peoples. They have intersection, that is people reading multiple newspapers, at least 2, and 3 is all 3 newspapers. The 3 people read all 3 newspapers. So we don't have to include them. Just we have to include those who read only one newspaper. Okay, exactly one newspaper. So this will be 8 and 10 and 12. That is 30. These we are not including because they read multiple newspapers. Okay, so it will be 8 plus 10 plus 12. That is 30. Okay. Now the same problem we are doing in another method. Okay, by mathematical formulas. Okay, so in here given, let us consider that H denotes the set of people, H, T and I denotes the set of people who read H, T and I newspaper respectively. Okay, you have to consider that the number of people reading H is given 25, number of people reading T is 26, number of people reading I is given 26 again. And what is the intersection value? H and I, H intersection I, both the people who read both H and I is 9. The people who read both H and T is 11, and the people who read both T and I, T intersection I is 8. And another thing is given, all 3 newspapers are read by that is H intersection T intersection I, that will be 3. So applying the formula, the number of people who read at least one of the newspapers. That is, we have to calculate the union of the 3 newspapers. Number of people who read at least one newspaper means we have to calculate the union of 3 types of peoples, H, T and I. So applying the formula, so it will be n of H plus n of T plus n of I minus n of H intersection I minus h of n of H intersection T minus n of T intersection I plus n of H intersection T intersection I. This is the formula for 3 non-empty sets union, 3 finite sets union. Okay, if 3 finite sets we take union of 3 finite sets, this is the formula. Okay, so putting the values, here will be 25, this will be 26, this will be again 26, this will be 9, this will be 11, this will be 8, this will be 3. Okay, so calculating those, it's 26, 26, 52, this is 25 means 77, 77 plus 3 means 80. Okay, this will be 80 minus 9, 11, that is 20 minus 8, that means 28. So answer will be 52. Okay, so the second portion, we have to calculate the number of people who read exactly one newspaper, just one newspaper exactly, no other. So we have to calculate n H only, then n T only, then n I only. Okay, so n H only means n of H, the newspaper reader who reads H. Okay, the people who reads H minus the people who read H and T minus the people who read H and I. Okay, now think, the people who read H and T, they might read H, T and I. Okay, the people who read H and T, in this set of people there are some people who read H, T and I. Okay, you have to understand this. The people who read H and T, there are some people in this set, the people who read H, T and I. Similarly, in the set of H intersection I, that means the people who read H and I, there are some people in this set who read all 3 newspapers, that is H, T and I. So we are eliminating the 3 newspaper readers multiple times, but we have to 2 times actually, but we have to eliminate them only once. So we have to add that in here. Okay, this portion already included in here, this portion already included here, but we have to eliminate this only once. So here 2 times it's been eliminated, so we are adding this one at the end. Okay, similarly for n of T, it will be H intersection T minus T intersection I. Okay, same method here also, 2 times eliminating the 3 newspaper readers, so all 3 newspaper readers. Okay, so we have to add this at the end. Okay, again for I, this will be n of H intersection I minus n of T intersection I actually, and plus n of H intersection T intersection I. Okay, now this will be like this, n of T plus n of I minus 2 into n of H intersection T plus n of H intersection I plus n of T intersection I. Okay, and plus 3 into n of H intersection T intersection I. So let's put the values. So n of H is 25, n of T is 26, n of I is 26 minus 2. How many people H and T? 11. How many people read H and I? 9. How many people read T and I? 8. And plus 3 into, how many people? All 3 is 3. Okay, very good. So this will be 25, 26, 26. That means it's 52 plus 25, 77 minus 2 into 11 plus 9 plus 8, that is 28, that is 9. Okay, so 77 plus 9 is 86 and 28 into 2 is 56. So answer will be 30. This is, we can solve this without diagram mathematically. So 30 people, number of people who read exactly one newspaper. So our last question is this: in a survey it was found that 21 people liked product A, 26 liked product B, and 29 liked product C. If 14 people liked products A and B, 12 people liked product C and A, 14 people liked products B and C, and 8 liked all of 3 products, find how many liked product C only. Okay, so we will be solving this using Venn diagram first, because it will be easy method. Here the people who like product A, here the people who like product B, and here are the people who like product C. Okay, so we have to find out how many liked product C only. Okay, so we will start from the common section. Common section means liked all 3 products. How many people liked all 3 products? Is 8. Okay na, this is the common portion. So next is how many liked A and C. How many people liked A and C? It is given 12 people liked A and C. So 12 people liked A and C means here it will be 4 plus 8, that is it is 12. Okay, now how many liked B and C? It is given B and C liked by 14. So this will be total 14. This is 8, this is 6 plus 8, 14. Okay, this satisfies. Now 29 liked product C, so this will be 29 total. So this is 14 plus 6 10, sorry 4 plus 6 10, and 8 plus 8 means 18. So 29 minus 18 is 11. So this will be total 29. Okay, so the question is given how many liked product C only. So the answer will be easy. The answer is 11. Only C only liked by 11 number of people. Now let us solve this problem using formula. Okay, so like previous problem, we are writing n of C only. Okay, how we will solve that? The formula is n of C, the whole one, minus n of A intersection C minus n of B intersection C, and plus we have to add the common one, n of A intersection B intersection C. Now you if you don't understand why this is adding just like previous one, so you have to just focus on the diagram. Okay, now what we are calculating? We are calculating this portion. We have to calculate only this portion. Okay, this is n of C only. Now n of C is the total one. Okay, minus n of A intersection C. A intersection C means this portion. This is n of A intersection C, those who like both A and C. This is, and n of B minus B intersection C means this portion. B intersection C is this portion. Now you just focus on here, A intersection C, B intersection C. The common element, that is 8 that is liked by the 3 products liking people. Okay, that is eliminating twice. It's included in here. One is A intersection C, another is B intersection C. It is eliminating twice here. We have to eliminate it only once, either in A intersection C or in B intersection C. As it is eliminating twice in this form, so we are adding this at the end. Okay, this is the reason we are adding. Here we are if you write the value, it is 29 minus A intersection C. A intersection C means it's A intersection C means 12 A and C. 12 people like both products A and C. 14 people liked B and C. Okay, and 8 is liked by all 3. 8 liked all 3 products. So it will be 29 plus 8, and this is 12 minus 26. This will be 37 minus 26, that will be 11. If you can see there, this is 29, n of C is total 29. We are eliminating 12. 12 means 4 plus 8. 12 we are eliminating 14, that is 8 plus 6, 14. So this 8 is eliminating twice here. One in 12, that is 4 plus 8, another in 4 plus 8 plus 6, 14. This 8 is included in here and here. We have to eliminate only once, so we added this one at the end. Okay, in the previous problem, this is why we added this thing. Okay, you might understand here. So this is how we can solve this problem.